Okay, now we're recording. We just covered the lose electrons oxidized, LEO, gain electrons reduced, GER, and then we start balancing this equation. But does everyone see how you get to this? And then you simplify. Simplify that. That's 10 H2Os, 10 H2O. That's 11 H2O. 6OH, 8OH. And then if you did all the charges, it would be negative, SO3 is 2 negative. H2O is chargeless. MnO4 has a charge of -1. SO4 is 2 minus. H2O is chargeless. MnO4 is chargeless. Okay. That took a while. Yeah, these are my least favorite part of chemistry by far. I remember taking this class last year. It was grueling, and this is definitely a chapter I got my worst grade in. But it's a good thing because immediately following this chapter, you go to the anodes and cathodes chapter, which was my favorite part of chemistry. So kind of one right after the other. But any questions on this? I know it's kind of hard to explain when it's not in person. I was trying to be there today, but I just had an exam and I wasn't able to make it. And if you ever need more help with these, they're all over the place on Google, on Khan Academy. You just look up balancing redox reactions and you'll get tons of videos because there's so many people that do struggle with this that it's just everywhere. So there's really nothing to worry about. If you ever start struggling with it more, just look it up on Khan Academy. They're really good at explaining it. I remember that's how I got through this unit. But I think we're going to go ahead and move on to the electrical potential in a cell, which, like I said, is one of my favorite parts because it's easy as soon as you grasp what she's trying to ask. And I think instead of doing all this stuff, I have a paper prepared this time if I can find it. Yeah, here we go. Let me see. Let me bring it up. Stop share screen. There we go. All right, y'all can all see this PDF, right?
Yes.
Okay, so this one, to be honest, I just looked up electrical potential of a cell practice problems, but I kind of read through them, marked off the ones that we didn't really need to talk about because they're covering stuff we don't learn yet or just don't learn at all in her class. But we're going to go ahead and go through the ones that I think we covered in today's lecture. So let me pull up the pen, and let's start with this first one. So how many electrons are transferred in the following reaction? We have 2 chromate ions plus 14 hydrogen ions plus 6 chlorine ions goes to 2 chromium ions plus 3 Cl plus 7 H2O. Any idea how to start? So the way I would start is we have 4 electrons here. Oh, this is going to be a lot harder than I thought. 4 electrons here because we have 2 times the -2 here. So we have 4. I'm in the middle of an SI session. Yeah. Okay. We have 4 electrons in this chromate ion. And then we move on to the chlorine, which has 6. Oh, that's not what I tried to draw. 6. There we go. 6 electrons. And then we move on to the chromate, which has 2 positive, or 6 positive. This is a lot harder than I thought it was going to be. And then the chlorine has no charge. So we're going from 10 to 6. So I believe, unless I'm missing something, I haven't actually checked this. Yeah. So we're going, or no, actually, hold on. 4. I'm missing something here. You know what? We're going to skip that one. Next. Sorry. I read through the rest of these. I just figured since that was the first question, I knew how to do it. And I was wrong. Pardon me. Okay. So this is kind of what she talked about in class specifically today. But the following two half reactions take place in a galvanic cell at standard conditions. What species are produced at each electrode? Real quick, does anyone remember what a galvanic cell means? Galvanic cell. A galvanic cell is when the, oh my goodness. Come on, PDF. No. There we go. The E0 is greater than 0. And that just means it's a spontaneous reaction, and the term for that is a galvanic cell. But that's not important to the question necessarily. What's asking is what is the anode and what is the cathode? And if you remember the definitions that she gave us, the anode is the electrode where oxidation occurs, and the way to remember that is anode, spell with an A. I'm not even going to try and draw it. Anode, you spell with an A, and oxidation, I just remembered by the vowels, so A and O go together, and then cathode, consonant, and reduction, and starts with a consonant. So the consonants go together and the vowels go together. That was the easiest way for me to remember it. But the anode is going to be where your oxidation occurs, and your cathode is going to be where reduction occurs. So now we need to discover which one is the oxidation and the reduction occurring at. Any ideas? Okay, so when you're losing electrons, shoot. There we go. Okay. When you're losing electrons, that's when you get oxidized. And so what we need to know is which one is losing electrons. Well, here with the selenium, I believe that's what that element is. Selenium, it has a +2 charge, and then it becomes neutral. What that means is it's gaining these 2 electrons, so it is being reduced. And then the copper is doing the same thing. Oh, wait a minute. This is not, okay, ignore what the question's asking. I thought this was asking a different question. You know, this document did not prove to be as helpful as I thought it was. Why is it? Okay, it's because this is backwards, which she hasn't explained yet. That's in the next lesson. Okay, so the question's asking a more advanced question that she should cover on Wednesday, because you need to know which one's going forwards and backwards, and it's a big old mess. But basically, the only thing you need to remember from this question is that the one that's the anode is being oxidized and the cathode is being reduced. Usually, it would be a lot more simple than that, because if you look at it, they're both gaining electrons, so they'd both be reduced. But I believe this one, since it's negative, it's going backwards. So that means that it is going to be the anode, and this would be the cathode. Confusing, I know. You'll understand it more after Wednesday. Let me kind of read these questions next before I try to get you all to answer them. Standard reduction potential for AG plus E is 80 volts. Okay, yeah, this is definitely one we can do. Okay, so we know that the standard potential, that's the E0 of the cell. Remember the equation is, try and draw it without it fixing it. E0 of the cell is equal to energy of the energy. It is anode minus cathode, correct? Did I not write that down? Oh yeah, there it is. It's cathode minus anode. Cathode, I'm just gonna put C A. Cathode minus the energy of the anode, which I'll just put A. Okay. And so we know that the standard potential, that's this one right here, the E cell, it's equal to 1.56. Point 5. Good Lord, this is rough. 5.6. The standard reduction potential for AG plus E minus AG is 0.8 volts. So we look at that and we say that standard reduction potential AG is gaining an electron. So it is going to be this one. And I think this is going to end up being another one of the backwards ones, which she also hasn't explained yet. And we'll get to that when we get to that. But so if you look at this, then the way you would normally solve this is 0.8 minus x equals 1.56. And then your answer would seem to be negative 0.76. And let me make sure real quick that it's not throwing us off. Ooh, crap, what question was that? 6. Answer is A. Yeah. Okay, so this is one of the normal ones considering. But in this scenario, you would have what I usually do when a problem is presented like this, I just start plugging in values. So if you start with negative 0.76, you plus, oh my goodness, come on, plus 0.76 because of the double negative, and find 0.8 plus 0.76 equals 1.56. So you know that is your answer. Oh, come on. 6, 7. Okay. Consider an electrochemical cell with copper electrode immersed in 1 molar copper and a silver electrode immersed in 1 molar silver. Calculate E0 for this cell. Okay. So remember, E0 for the cell is the cathode minus the anode. So we need to find out which one's the cathode and which one's the anode. This is one of the backwards ones because they're both viewed as forward reactions where they're gaining the electrons, but we need to kind of think beyond the box. So what we need to know is 0.34, 0.84. Trying to think back. No, this is another one she'll do on Wednesday. And then I think the rest of these are all, okay, yeah. Okay, that did not pan out as well as I thought it was. I kind of remembered things she did last semester more than I remembered this semester. Oh, are we about out of minutes? Oh yeah, we have less than a minute. We'll talk about more of that on Thursday of the electrical stuff. It's a lot more confusing and it requires her to kind of explain more. But real quick, if y'all could put in your